In this video, we'll start a brand new topic called integration. And essentially integration is about area under the curve. So if we have this curve from 1 to 2, it sort of makes this shape almost like a triangle-y shape, but very bendy. And then you could sort of color in the inside of that shape, and we'd be looking at finding that area. Now we have area formulas for nice shapes with straight lines like triangles and squares and stuff, but we don't really have an area formula for a shape like this. So integration is going to be really powerful. Pretty much as long as you can make a curve that has a particular shape, you can find the area of that shape. Pretty cool stuff. So that's going to be the premise of it. And essentially we're going to be breaking up the shape into a whole bunch of rectangles underneath or above the shape. So I'm going to do an example for 2 rectangles here, and then we'll do an example for 4 rectangles. So when we do 2 rectangles, we have something called the upper and the lower estimate. So the lower estimate is going to look something like this. This first rectangle is going to come down like that, and the second rectangle is going to look like that. So we're only going from 1 to 2. So I want to split that region from 1 to 2 exactly in half. So 1.5 is halfway through. And because this is the lower estimate, the rectangles are going to be underneath the graph. So how do we find the area of a rectangle? Well, the width of this rectangle is 0.5, and the height's a little bit trickier, but pretty much the height of that rectangle is going to be whatever this function equals at 1. So the red line is the function there. We can see that at this point here would give us the height of the rectangle. The x value is 1, and the y value is whatever I get when I put 1 into the function. So if we look at that, so x is 1, f of 1 is 4 lots of 1 cubed. The function I'm looking at in the video here is 4x cubed. So that is 4. So that's going to be this rectangle here. The height is 4. So if we look at the area of that rectangle, it's going to be 0.5 as a width times 4 as a height. Okay. By the way, that gives us 2, just in case you're wondering. Let's look at the area of the next rectangle. So the next rectangle, it's going to be a width of 0.5 again. And the height here, well, the height is going to be f of 1.5. So that's going to be 4 lots of 1.5 cubed. And we can just chuck that into a calculator and work it out pretty much. Now, the only reason that's the height formula is because this is the specific function we're looking at, 4x cubed, but it's 13.5. So the next area is 0.5 times 13.5. So the area of that first rectangle was 2, and the next rectangle, we can sort of see what it is. So 0.5 times 13.5, you get 6.75. So that area is 8.75 square units. And I'm going to call this area L for lower area. Okay, so we'll get rid of all this. Next, we're going to do the upper area. So the upper area is going to look a bit different. We're going to go to the top. So basically, these rectangles are going to be sitting above the function. So that will be one of the rectangles there. And sitting across like that will be another one of the rectangles here. So for the area upper, pretty much the first rectangle is going to be 0.5 times, now it's this point here, and we actually worked out what that point was before. It was 1.5, and I think 13.5 was the height. That was the same as the height of this last blue rectangle there. So that's good, 13.5. And then the next rectangle is 0.5y. And this has an x coordinate of 2 because we're sort of matching that x point down there. And then we've got to figure out the height. So for this height here, it's going to be 4 lots of 2 squared, cubed, sorry. So that would be f of 2. Yeah. So that's 4 times 8, or in other words, that's 32. And you can usually tell from these graphs, like it does look to be at about 32, so that's a good sign. So the next rectangle is going to be 0.5 times 32. If you want, you can actually speed this up a little bit by pulling out 0.5 as a common factor. That pretty much always works. So let's see what we get. 0.5 times 13.5 plus 32. So our big area is going to be 22.75 square units. That's area upper. Now, if we want to take sort of a guess at the area, basically we just take the average. So area is area lower plus area upper over 2. You literally just average out the two areas and you get something halfway in between 8.75 and 22.75. There we go, and halve it, so we get 15.75. That's our best guess of the area so far, 15.75 square units. Okay, now let's do it with 4 rectangles. I'll do this one just a little bit quicker, but basically 4 rectangles is going to look like this. We're going to split the region into 4 equal parts. And so the area lower, so each of these rectangles are going to be 0.25 wide. So it's going to be 0.25 times. And then to get the height of this rectangle, this is just f of 1. So it's whatever I get when I plug 1 into the function. And then we can sort of go 0.25 times f of, the next height is going to be f of 1.25. So that's the x coordinate there would be 1.25. It's halfway between 1 and 1.5. So we can work out what that is. And then so on and so forth. So 0.25 times f of 1.5 plus 0.25 times, and then the last one is going to be f of 1.75. So I can pull 0.25 out as a common factor if I want again. Now the easiest way we can sort of work out what all these are is you can actually graph the function. So the function we're looking at is 4x to the power of 3. Draw that. The window is going to look a little bit different. So my window goes from 0 to 3 and about 0 to 40. We'll draw that. And you can just go trace and type whatever values you want. So if I trace at 1, I get 4. Next one that I need to work out is f of 1.25. So if I trace at that, I get 7.8125. Next value I need to work out is f of 1.5. 13.5 is what I get there. And last value I need to work out is f at 1.75. So trace again, 1.75, 21.4375. Okay. Now, if we want, we can just work out what that is. Just chuck the entire thing into a calculator. Okay, so if we look at that, 0.25, and it's 4, 7.8125, 13.5, and 21.4375. Cool, 11.6875. Square units. Okay, we can calculate the upper area. Now the upper area, let's do that in a different color. Let's do it in blue, or maybe in green. The upper area is going to be all these bits. So just the slightly taller rectangles. So it's still going to be 0.25. And the upper area, so the height of this first rectangle, I pretty much just have to read off this x coordinate right here, which happens to be f of 1.25. So it's almost like what the last calculation was, but everything's sort of shifted right, and then you have this extra one on the end. So the last rectangle we haven't seen before, a rectangle this high, but this is just the x value there would be 2, so the y value is f of 2. That's how high that rectangle is. Okay, so we actually know what a lot of these numbers are already. F of 1.25 was 7.8125. Next area was next height was 13.5, 21.4375 was that second to last one, and then f of 2. If you want to work that out by hand, f of 2, that's 4 lots of 2 cubed, which is 32. So that last value is 32. Or if you wanted to do it on your calculator, you could go into your graph mode and then just hit trace and type 2. You'll get 32 as well. So we can work out what this one is. Just chuck the entire thing in the calculator and we'll see what we get. 0.25, 8.25, 13.5. Next one was 21.4375 and the last one was 32. 18.9375. You might notice that these guesses are a lot closer than the first guesses. Reason being, because we've taken more rectangles, we're sort of getting closer into that red line and getting closer to the tree area. So my guess is that the area would be the average, so area lower, area upper over 2. And that would equal, so it's 11.675 plus 18.9375 all over 2, so 15.3125. So our first guess was 15.75. That was our first guess up there. Our second guess was 15.3125. And we're getting closer and closer to the real value. If you want, you can actually do this with heaps of rectangles. So I've got this graphed. The window's a bit funky because the y values are so big. But you can see that if I do n equals 2 rectangles, we've got those same upper and lower sums there. If I do n equals 4 rectangles, same thing there. And then if you do something like 100 rectangles, then you got 15.1 and 14.8. They basically average out to the tree area, which happens to be 15 in this case. And why is it 15? Well, that's the exciting thing about this topic. We're about to find a way to find these areas exactly, and we won't have to do this rectangles method for very long. Although it can come up in exam questions, so it's really important to know how to do this rectangle thing.